Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 72, count good triplets in an array. So for this one, I'm not gonna lie, hit the like button, hit the subscribe button, join me in Discord. But to discuss this problem maybe in a more timely manner. But I struggled a bit with this one. I think the two observations that I made is that one is that you can, instead of having two arrays, so there is a straightforward dynamic programming solution, right? Which is almost like a longest common subsequence type thing, and then you do a count on having three distinct matches, right? So that's an obvious one. But however, you look at the n, and n is 10 to the fifth, and it's gonna be too slow. One reduction that I actually should have known a little bit better, but took to my time to do, is that you can actually reduce this to longest increasing subsequence um, by um, by remapping the numbers, right? And what I mean by that is that, for example, um, you have these two. Maybe no, I didn't. I got rid of it anyway. You have this number. Another way to think about this is that, okay, four, what is the position that's in here? So then now the position zero. This zero, where's the zero? Right, zero is in index two. One is in index one. Three is in five or four rather. So then you have this new array that basically is saying, okay, so this four is in position zero. This zero is in position two. Dot, right? And then now the problem is just doing it longest, or not longest, but like an increasing subsequence on this, because if you have 0 1 3 is one, and you could kind of mash them up, right? Because 0 1 3 just means 0 4 1 2, which means 4 1 2, right? Because it's just keeping the relative order. So once you do that, one thing to say is that dynamic programming for longest increasing subsequence, or variation of it, is still n square in the worst case, right? So it took me a long time to get it, but then, well, one is that, to be honest, this mapping that you just see me do, I think I am in Cartagena right now. I think I might have drank a little bit too much for earlier, and I think I mixed up my internal mappings. So I used a different formula, which I took a long time to realize that, oh, I not formula, but like, I was going with my gut, and my gut was really wrong, to be frank. So I had this other recurrence, or not recurrence, but just like another snippet of code that it was in my head, but then I kind of mixed them up. So I didn't even think about it until I looked at it deeply, and I was like, oh, this part is wrong. Otherwise, all the other code is kind of right, except for that it took a long time to write. Um, but yeah, so once you make this reduction, you can see that, yeah, and then the key thing to know for this problem is that you only have three numbers, right? So, or you three distinct ordering. So the way that I did it, I'm going to give you a cleaner solution after this, but I'm also showing you the solution that I tried during the virtual contest. And because this is a virtual contest, I think I articulate this as I'm writing it pretty okay. So definitely check that out if you're just curious, and fast forward, watch on the fastest speed, whatever you need to do. But I recommend that, because I just had it wrong. But yeah, basically the way that I was trying to build is off the same idea that is in dynamic programming, right? So basically, I have three states, right? One is uh, one is basically, well, one is just the number of subsequence that ends here of length one, and so same for two and three, right? And that's basically the idea that I was thinking of. This is just every number, right? So every number by itself, right? So that's just, obviously that's easy because that's just every number. Two is basically giving this, how many smaller numbers are there before me, right? For example, if this is four, you can see that the three numbers before the four that are smaller. Well, I guess this is every. And of course, that means that What does that mean, right? That means that because the three numbers smaller than four, you could use any of them as the first number, and then four as the second number, right? So that's basically the idea I had here. And then the third part, so this one, I think hopefully part one and part two is makes sense and pretty reasonable, etc., etc. If not, leave a comment below or in Discord. And the number that ends here of length 3 is the part that I struggled with. Or not really, but I struggled with coming up with a better solution. And the idea that I came up with was just this idea of prefix sum. And when you think about prefix sum that you have to upgrade dynamically in a fast way, I think Fenwick tree, right? The idea is that, okay, let's say you have a 4, right? Now we know that in terms of prefix sum, 4, we know that there's 3 numbers smaller than it, right? So then that means that for 4, we have an entry of, let's say a prefix of 4, we set it to 3. Because in that case, we know that if we want to continue on the 4, there's 3 sequences that has 4 as the length 2, which is what we did, right? And then now we added, and then using Fenwick tree, I'm not going to explain Fenwick tree in this video because it's just complicated and a little bit, and also it's just very long, right? I'm just trying to, get you with enough material so that you could Google it. But this is just prefix sum. So basically, I would say Fenwick tree is just a magical thing that gets you the answer of, for example, later on, let's just say for whatever I have a 5, right? Now to get the 5, I go, okay, what is the what is the total of this thing of smaller numbers, right? And prefix sum and a Fenwick tree lets me do that. Let me get the sum of the first, in this case, 5 numbers that are smaller than 5, and that lets me get the sum. And then you just sum it all up. So this one I'm not happy with the solution. We'll go over the code real quick. It is kind of what I said. This is actually, this code doesn't look very nice, but it is exactly what I said, right? We do the lookup on the index, we convert it to a list, and then yeah, and how many small numbers there before me, I actually used a sorted list, though you don't really have to. You could use other things. Yeah, and then that's pretty much it, really. I sorted list, and then the total. This is the sum of the prefix sums, like we talked about, the prefix sum. The smaller is just we do a binary search on the sorted list. And then here, this is just incrementing the one of length 2 so that it can be used later in the Fenwick tree. And then we also add X to the sorted list. Okay, let me show you all my code in one thing so you could kind of look at it. Like I said, I'm not happy with this, but it's fine. This is going to be log n, this is log n, this is log n, this is log n. So this is going to be n log n solution. Yeah. And O of n space. Yeah. Like I said, this is fine, but it's not what I'm happy with, to be honest. And because I did do this as part of the virtual contest, and actually I thought about this right afterwards. I was like, this is a little bit awkward. No, it requires machinery that I don't think really is necessary. And this is where I came up with the second one. The key thing to note in the new solution is that we're making 3 distinct values, right? And then from that, it means that if you have the middle number, then all you have to do is look at the smaller number and the bigger number. So basically this part, and then instead you have almost like a pyramid, right? So that you go from pyramid going up and then the other direction going down, and then you kind of join in the middle of the two. And that's basically the idea I have here on the second one. And this code I am more proud of. But basically it becomes a sort of a sweep line algorithm. Basically, I have a sorted list of all the prefix, sorted list of all the suffix, and then I go, okay, how many numbers are smaller than me, right? I mean, this one I put it here, but you can add it to the end. It doesn't really. Oh, I guess it does matter because of if the X is in there, then it includes one more. But that's enough by one. It's fine, right? And then now the suffix is, let me count the numbers that are bigger than me, right? That comes later. So then that means that I am the middle, and how many numbers on the left, how many numbers on the right, not how many numbers, but also for each number it's a selection. So then you multiply them together, which I did here. So this is how many smaller number, and this is how many bigger number, and then you add it, and then that's it. And then you obviously move the prefix to include X so that you have it. This is also gonna be n log n, but it's much cleaner, much tighter. I'm a much fan. Yeah. That's all I have for this one. Let me know what you think. I'm losing my voice a little bit, so yeah. You could watch me start with live in the contest next. Like I said, you can kind of see my dubious solution, but you know sometimes these contests, a dubious solution is still an ACN. That's it's good enough. And when you have more time, you could make it prettier or whatever. Anyway, that's what I have. You can watch me sub it live next. I'm a little bit rushing a little bit, maybe. Maybe I should take. Okay, maybe not. That's fine. Okay. I can't go triplets in a way. So, three distinct values in which increasing order by both. Okay. So in this case, I'll say what? 201, what does that mean? Just the first index? Okay, yeah, that's right. 013. I don't understand this, so let's read it again. I don't know what this notation is. Okay. Index of value right in number. Okay. Okay. So then 013 and 013. Okay. So is this his longest? Oh no, I was gonna say longest increasing sequence, but I think this is just DP with 3 or something like that. Something weird. Excuse me. So 403 and 403 is in the same order. Okay. Let's see. Yeah, I think this is just DP on the 3 thingies, right? You start with the 4, just 0, you build off. Okay. I've tried to figure out how to write this in a good way. I mean, this is odd. I feel like people are very good about this, but okay. Is there fireworks going on outside or something? I don't know. I think there is fireworks outside. I'm missing some fireworks, so I hope you appreciate it. But okay. How do I want to do it? Okay. Maybe I'm not doing this right. Okay, so 4. How am I phrasing this? So we go index 1. Am I thinking this way? Maybe I'm just hand wavy a little bit. So 4, we know that it is the, yeah. Well, at least like what I think I am trying to do is maybe n square. So maybe that part is wrong. So now we can go to the 1 and it's not necessarily, but let's see. Let me think. Okay, so let's say we go to 0, right? 0, we mark to 0. And then here we have 2 and 3. And 2, we say what's the common preset of 2, right? Well, 2 can have, okay. Eh. How do I do this in a good way? Okay. So let's say we do top 4 as you go to, I still feel like it's DP, but I'm not doing it quite right. Or like, like 3-level DP or something like that. Before you look up to 4 and the other 4, right? And let's say with 0, we look up to 0. What does that mean? That means that I think the part that I'm struggling a little bit is trying to figure out how to do it in linear, or maybe n log n, maybe say. Basically, you have some like longest increasing or longest common subsequence of length 3 or something like that, right? And LCS is obviously very big. Well, not longest, but the number of common subsequence, and that's like a very trivial n-square solution actually for dynamic programming. But now we're trying to figure out how to do it in not n-square, right? Okay, let's see. How can we look this up, right? So let's say we're going from left to right. How do we pre-process this? Let's say we have 0. We match the 0 here. Okay, that's fine. How do we process the pre-things? Okay, let's say 4. Let's start 4. 4, what does that mean? So 4, we have no prefix, so here's the 4. Right? Okay. So then, what does the O mean? O means that, okay. And then we know that the previous number, 1 already exists. I feel like there's a count way of doing it, but and then at the 1, this one, and we basically do a set intersection. But that's still going to be n squared because I'm not being careful. And also, when we get to the 2, we have to be able to figure out the 2 paths to it, right? Maybe I'm thinking about it in a stupid way. Let's see. These are permutations. Does that mean anything? I mean, going backwards is the same, right? So I don't think there's anything there, but 0, 1. Let's see. Can I do anything sliding? Don't have a great answer for this one yet. Maybe this isn't right. Let's see. Let's see. Wow, I'm really bad at this today. So okay, so let's say we pre-process it, like almost like a breadth first search. How would that go? So 4, we go da 1, we do and 1, we know that there's a 4. I don't know. I don't think that's the way to do it though. Um, yeah, I don't know. I'm gonna. Wow, a lot of people already finished. So that wow, 6 minutes. Jeepers. I mean, I thought I was fast. I mean, I would have been if I finished Q4 in 3 minutes, I guess. But that is ridiculous. Okay. Oh, and good job, Josh. Um, where am I? Oh, I'm 18. So I'm actually doing pretty okay in the fake rankings. Considering a lot of these people also did Q4, right? But I don't know how to do it. Let's see. All right. Let me see if I could think about this in a better way. If they're both exactly the same, then I guess you just n choose 3. So the worst case answer is gonna be n choose 3, right? Which is n to the cube over 6 or something like that. But that's not gonna be fast enough. There's no way. I guess the question is, can I sort one in the order of the other, and then it becomes easy, right? Like here, then we already know that if we sort at numbers 1 instead of numbers 2, then here you just have to look at the number of increasing subsequence, right? And that should be okay, maybe. Yeah, maybe that's it. Okay, let's try that. I still have the idea still shaky in my mind actually, but here you just have to do the number of increasing subsequence of 3. Can I figure how do I do that again? Out of a binary search. Is that really right? Because then you have 2, okay, and then 0. And 1, what does 1 mean? 1 means that, okay, that's the number of smaller numbers that previously before, which is 0. How do I do this? I think I have an idea now, though, at least. So then here we can sort, yeah, let's just say, what's it called? Sort this. So enumerate between I and X. So we sort it by, whatever. So T of, so T of 0 is the I, and then you have numbers of 2 of that. Okay. I think this is right, maybe. And then, yeah, okay, let's just print it out. Let's see if that works. Okay, so that does seem like it's working because this is returning 2013 because it didn't change. And here's running 10324. Okay. And then now we have to get the number of increasing of length 3, which is 024, 124, which is 2. Is that the answer? What's the other 4? And then 034, 024, right? So that's 4. Yeah, okay. So I think I'm more confident now of this idea. But yeah. Okay. Right. Okay. So then now we have to get the number of and of course that I mean that still has an n squared solution in the naive case. I forgot how to do it in I mean I know how to do well that's the longest, not the increasing subsequent, right? So here, okay, let's say I have to maybe I think the smarter people will be able to get this, so that's why, but okay. So we start with 1, we go to 0, we start with 1, so length 0, okay. And then 0, we go, okay, there's no smaller numbers, so, yeah. Then 0 has Okay, let me play around with some ideas. Okay, so as equals sorted list, say for x in nums 1, we go, okay, so we now try to count the number of smaller numbers. Does that make sense? I mean, it makes sense for being the first number, but then now we have to get the second number, and we have to get the sum of all those things. Is there an easy way to get the prefix sum of all that stuff? I don't know. Like, for example, we want to get the third number. How do you get the third number? So here for some for 4, we have to see that 4 small number exists. So that one is easy to forget one number before that. And 4 has, I guess, 4 numbers behind it, but then now we have to get the sum of all the other things. Do I need a binaries index tree? Maybe that's how. Because basically 0, you have 0 numbers, and then binary index tree, I put a 2 before. So now you could do 4. At 4, there's 4 numbers before. 2, there's 1, 2. So then the 2 had 2, and okay, well, maybe do another way. 3 has 2 numbers before, so if 3 is the second number, it would have 2 paths, right? And then when you get to 4, you just go, okay, well, 2 has 2 paths, 3 you have 2 paths, and then here 4 you go, okay, there's just yeah. Okay, I think I'm convinced, but I'm always a little bit weak on binary index trees, so let's yeah, okay. Let me figure out. I'm just trying to find my old code. On the side, I used to be able to Google my old code and it shows up. Man, wow, it really dropped off to yeah. Jeebus. Why is it that I don't get it, but okay, fine. Okay. So then now, okay. So the sorted list will allow us to get how many numbers that are 1, right? So this is going to be a little bit tricky, so bear with me. Because I don't know how to do it myself, or like, you know, I'm trying to think about it myself. Okay, so then let's do the do. First 4, whatever. Okay, and then increase of index delta. What do we do? I should. Okay, fine. I feel like I should. Yeah. Wow. Text is in length of 3. That's afterwards. It's been a while since I remember this, so I don't know. Let's just go total. Text +1. Okay, there we go. Right. And then here basically is saying, well, we're going to add x later. Smaller is equal to SL dot bisect rate of x. Well, x doesn't show up anyway, so it doesn't really matter. And then we increase x with smaller. That will give us so this gives us the numbers that have two things. And then now, maybe something like this. Yeah. Okay, I forgot it again. I think I did it recently as well. But I'm focused on the other part, obviously. This is the relatively easy part. 1 and 4. All right, let's give it a submit. I don't know if this is right, but it's fun enough to give a submit. Oh, Okay, so I'm really wrong. That's a little bit unfortunate, actually. How many people got it so far now? Well, a lot of people got it, so I'm really sad. Why do I have, so knowing that my answer is worse than the expected answer is kind of sad, because then now, maybe I don't have any idea then. Okay, so we have this thing. Let's see. I was just double checking whether there's a small index or whatever, but so the smaller is the number of ones. Okay. Total x is prefix, right? Did I mess that up? I think there's two. I think I sometimes mix it up to. Yeah, no, I think this is right, but or like my implementation of what I expect, but yeah, I mean x doesn't show up yet, so I think it technically is x minus 1 inclusive, but so 0 0, yep, 0 5, and maybe I should print out x as well. Okay, so 5, there's 0 numbers before, that's fine. Small, there's 1 number smaller, yep, and then answer 0, I guess that's fine. 15, there's 1 answer, that's true. 0, there's still only 1 answer, that's true. 4, 4 has 2 smaller numbers. Right, yeah. Am I miscalculating it? Maybe. 2, we still don't have another answer, because, okay. But I think like this reduction is right. I'm just messing it up. 6 when it comes to 12, because let's see if that's right. Let's see. It's such a mess. Okay, well we can do something about that, because here, if this problem is equivalent, we should have, oh snap. Oh no, that's the input. If the problem is equivalent, then this number should, yeah, that's 1 2 3 0. Oh, is there a 16 here? I can't find. Oh, I just missed the 1. That's an odd thing to miss. Okay, so I think this reduction is right to this thing, but my thing is clearly wrong. Okay, but then now that means that I can reduce this to maybe not, or like not easily. That's annoying though. Okay. Now we can say, well, at least like it has the same reduction. I don't know. Maybe that's just wrong actually. I can say that is right. Let's say up to the 12th. So the first. I don't know. Do it again. So the nope. Oh no. Okay. But this one, I'm getting. Of course, it's not verbal, but maybe I translated this wrong actually. Oh yeah, I missed the number. 5. Oh, this is 6, I guess. I thought there were 6 numbers or 7 numbers. Okay, so this is 6, same as here. I actually don't know what the expected answer is. I thought I would get it, but okay. So we have an equivalent one. 6, does this make sense? Is 6. Yeah, 0 to 5 is 1, so 3, 5. Well, 1, 4, 6 is obviously 1, 1, 3, 5, 1, 2, 5. So that's 2. Okay, so how many contributions are there from the 2? 2 contributes 2 from no, just 2 from 1, 1 from 0. Okay, so 2 is 2. I don't know what I'm doing here. Okay, I'm just not doing well. Okay, fine. I can also do the brute force one to get the answer as well, to be honest. But okay. Then here 16 is the really weird one, or maybe not. I don't know. Okay, let me do the n squared solution. I think that's what I would do to double check my answers. Nope. This isn't right, but so actually what we want is okay. Okay, so what does this give me as an answer? I guess all the sum of the last one is what I want. Yeah, okay. I still print out 87. So maybe maybe there is something wrong with my reduction then, and that my math is right, but the reduction is wrong. Okay, maybe that's why. I thought that this reduction is good, but I seem to be wrong. Let's just do it here. It's still printing 87. Am I misunderstanding this problem? Oh no, This is not that brute force, I guess. This is the brute force on. So this is checking this part, but it's not checking on the reduction part. Okay, so maybe my reduction is wrong. Hmm. Uh, yeah, whatever, why not? We're using infinite space. Okay. Maybe I'm just being a dummy. No, that's still ends. Okay. This section may be wrong. It might overcount. I guess my reduction is just wrong, and also this is overcounting by a lot. Maybe I don't know how to do DP. Okay. Well, this is yikes. I thought that this reduction would be right, to be honest, but clearly it's not. No, is it though? Decided that I'm just sorting it wrong. Let's see, what's the input? So input is 0. Wait, maybe I'm just doing it wrong. Okay, so this is the input. Well, this input, we'll look at this input. Okay, fine. This is the input, right? And we sort by the second one. Maybe I have to sort by the reverse of the second one. Maybe I messed that up. Maybe that's it. I didn't check that tight enough. Because 0 means that the first number is 1. Okay, 1 is 5. Okay, but maybe it's a variation of this and I'm doing it wrong. Because I think 13, maybe that's what I'm doing wrong. Is it though? This is very weird that, because I don't think this makes sense as a transformation of this, because 13 is a very big number, right? And that doesn't make sense that, that it would reduce to a 1 even if you do it in some funky way. Maybe I just didn't audit it that well. It is something like this, but I'm just getting it wrong. Because, okay, so if this is this, then that's fine. So what we want to do is we want to, I think this logic made sense, but I think, or this observation is something that makes sense, but I think I'm doing something funky, because you cannot just sort the second one, and I think that's what I'm doing, and that's why this is wrong. But it's something like that, which is why people are able to get it this quickly. Maybe, I don't know. Yeah. So 13, how do we map this 13 to something that we can use? Right, because the increasing part, it's not just matching, right? It's not longest common, it's longest increasing. So I think that's where I messed up because I converted the 13 to 1 for some reason, which obviously doesn't really make sense because this one maps to this one, which doesn't have even the same thing. I'm really messed up here. So I definitely didn't really check my thing. I think this part is still reasonable if we can run into one away. I don't know how to do that yet though. So how do you do? Okay, so this is 13. Oh, it doesn't have to be. Oh, I'm wrong again. I think I mixed it up. It's increasing order in the second array. So the 13, I think I just need to sort by the reverse word one or something like that. Because the 13 is actually instead of 1, we need to look at the index of the second one. Okay, I think I just messed up. I confused myself. I think I used the other mapping or something like that. Okay, let's. Also, I think I just tried too hard to make it one liner. So let's go. Okay. Nums 2. Lookup of x is equal to I. Okay. And then now we go. Okay, I think this is just lookup. Okay, let's run it real quick. Let's just enumerate. Okay. Wow, I am just. Okay. I mean, I was close maybe, but a little bit sloppy in the thought process. Okay, so this is still the wrong answer, but let's see if that actually makes a little bit more sense at least. So the 13, is that this one? Okay, so something's still a little bit wrong because 13 is not the 15th index. 1, 2. So I need to replace this. I think I'm just still sorting for some reason, but I have to actually replace this with the index of the other thing. So what I want is actually not a sort, but a lookup of x for x in nums 1. Okay, there we go. I am just being silly. Yeah, okay, well. Give us submit real quick. Hopefully it doesn't time out. Yep. Oh man, I am. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, especially just come to Discord. Let's hang out. Anyway, stay good, stay healthy, do good mental health. I'll see you later. Bye bye.